Hello, welcome to another episode of Beam There, Done That. Again, I'm joined by my very wonderful co host, Francesco.
Hi there, I'm Francesco. Yep, host at the Beam There Done That podcast. I'm the one telling you, yeah, we used to do this in Erlang. And yeah, we've got a great guest today.
We have Kim, who is the CTO at Nexus Scale.
Yeah, I'm happy to be here.
Welcome. Why don't you tell us a
Today,
little bit about yourself and your background?
yeah, my name is Kiprotich Kimutai, but people normally call me Kim. I am a full stack software engineer. I have been working with Elixir for the past close to 4 years, and I am currently the CTO of NexusScale.ai. We have built an AI sales agent that can send automated can find leads, send automated marketing emails, and follow-ups to potential targets. And I'm happy to be here and to chat about how we used Elixir to build the infrastructure for the agents for NexusScale.
I always love it when we've got actually real world examples. I mean, if we look at it, I mean, the reason we reached out to you today is to talk about how Erlang style concurrency, which obviously any language in the Erlang ecosystem, including Elixir, has adopted, enables building autonomous AI agents, which handle very diverse tasks at scale, and especially considering you're actually using it for your real world applications and have real world examples. I think that's going to be super cool. Kim, how did you come to build AI agents in Elixir, and what was that journey like?
Okay, it started further than NexusScale. I was working on a research project funded by Wellcome Trust and University of Warwick, where we were building a WhatsApp chatbot agent for community health workers to enable them serve patients with sickle cell anemia better. So we were building it as a framework for other people to use it for other diseases if they wanted to use it. So that is where it all started. I gained interest in AI, where we explored different models like Mistral, OpenAI. It was still very early on, and we had to do a lot of training and tuning. And we actually considered building a custom model at some point. But then, so it was a research project, 2 years, 2 years project. Then I joined a company in Kenya which was using Elixir. So I started learning Elixir, and when I really loved it, the way you think about processes, concurrency, fault tolerance. So I started building simple chatbots using Elixir. I actually found a library called LangChain for Elixir, which was quite interesting. Yeah, but the way I thought about it is I mapped an AI agent to Agent Server because Agent Server normally has state and it can manage state. You can pass message from one process to another. That's how I thought about it, and I decided to do more of that. Then the perfect opportunity came, Nexuscale, where sales teams are working in a fragmented tools, so you have to navigate different tools to do something simple. So we came up with Nexuscale, which would help sales teams to just use one tool, which will have different agents. It would help them find leads, send emails, send follow-ups, and so on. So that's how I came into this.
Great. Yeah, it's something which resonates with what you said is, this concurrency kind of felt natural. It was a nice, it's what got you into Elixir. And yeah, I just want to remind everyone of Armstrong's tenets. Concurrency is a natural way of thinking. The world is
Yeah,
concurrent. We share, messages with each other, through message passing. We don't share memory, we don't
yeah,
share brains. We share it, and I'm now broadcasting a message, to everyone listening to the podcast, and they go in and they retain, those parts they want, but it's their own copy in their own brains. And finally, things fail. Go out, get hit by a bus. Supervisor comes in and
yeah,
brings me to hospital, and I recover, and then I continue running. And I think it's a very natural way of thinking, which adopted to which when applied to to programming, makes the way code more natural and easier. It makes the world and your problem easier to think and reason about. Now, I had a question
yeah,
following up what you were talking, because it was really interesting how you first got into chatbots and AI, and then later into Elixir. And basically, I think that's the right route, because you really realize that you've got the right tool for the job rather than the tool at hand. My question, here, based on what you're telling, what is an AI agent? And I think a lot of listeners might not have had interaction with them or programmed them. And how is it different from a chatbot?
Chatbot is basically reactive. You send a message, it responds, but an AI agent is different because it can act autonomously over time. The simplest way to explain it is a chatbot answers questions, an AI agent completes tasks. And an AI agent normally has three components. There's the brain aspect. This is the language model that does the reasoning and decision making. Then we have tools. An AI agent needs to have access to external tools that can do various things. For example, Google search, if you want to make an API call to the outside to get some information, or even accessing tools within your laptop, as simple as maybe capturing a screenshot or anything similar to that. And then another one is the context. The context is whatever the memory the agent has or the state it carries. I can just use state for now because you're talking about Elixir. So this is what it knows about the current task, the previous step, the goals it's supposed to achieve, and the current constraint. How I normally think about it is think about it as a person at work. Like you have your brain, which is your intelligence. Then you have tools, for example, if it's a laptop or your phone, to access different systems. Then the context is everything you remember, the brief you are given, what you've already done, and what is still pending. So that is an AI agent.
Actually, what I find to be pretty interesting is that you don't often hear people using languages on the Beam for creating AI agents. Now, what
Yeah.
made you think to actually use Elixir or Erlang? Or you're using Elixir, I believe, right? So, what actually
Yeah.
made the Beam come out to you as a possible language to use for this kind of task?
The main reason I chose to use Elixir is because it's built on top of processes. So, as I said before, an Elixir agent server is basically an AI agent. So they can communicate with each other through message passing. And in Elixir, you can spawn so many lightweight processes that are cheap. So you can easily spawn different agents with their own fully isolated state. Because one state once processes state should not feed into another's. That was one thing that made me use Elixir, really love Elixir over Python because I was using Python before. Another thing is supervision trees. So agents might experience different issues. For example, an API failure. So the good thing about Elixir is that a supervisor agent can just restart the failed process. Yeah, and it continues working without the whole system going down. And another thing is fault tolerance, which is still tied to the supervisor agent.
Well, it all boils down to, the no shared memory approach. I mean, shared memory is evil, as we usually joke, right? So,
Yeah.
for those who are listening in, considering using Elixir, for their agent frameworks, but haven't actually coded, how do all of these agents coordinate with each other? Because I suspect, there's a lot going on, and they're not sharing memory. How do they coordinate and exchange information?
Okay, so at the simplest level, an agent is a Gen server with a well-defined interface, I'd say, because you have to add the brain and the memory. But one agent can complete work, for example, then it sends a message to the orchestrator process. So the orchestrator process decides what happens next, which agent gets triggered, the context that gets passed along with it, and the overall state of the task. You typically maintain a task level process that tracks the overall state. Then you persist over across. It's persisted across a managed server. If you design it like this, for example, if you have two agents, one is for research and the other one is for writing. If you decide to add a third agent, for example, to adjust a tone, you can just add it as a new supervised gen server that understands the message process protocol. Then you slot it inside the supervision tree and the system works without changing a lot. So that's the beauty of doing it like this. And there's also fault
Excellent.
tolerance
Yeah.
that that comes with that.
It's basically the whole idea of supervision trees, but also fault isolation. So if an agent fails, all of the other agents who are doing work around it, continue executing, continue running, and all you need to do is
Yeah,
recreate the state of that agent which failed. Which might not be easy, but it's doable. That's where you focus more on recovery more than avoiding edge or borderline cases, which are very very hard to
yeah,
avoid.
but the good thing with Elixir is that you
Yeah.
can the processes or the different agents can just communicate with each other. So if you need to pass information, you just pass information directly.
We just finished a project where we needed to handle the context of the conversation, for hours. And this project's been going on for about 1.5 years. So, it was very little about context, which, previous in your sessions used to last 10, 20 minutes. That's different now. Looking at what we have available today, how do you handle context and memory for agents at scale?
Context is genuinely the one of the most hardest thing in agent
Yeah.
design because large language models normally have a context window. So it's normally a limit of how much they can reason at once. So if you're running a long running task that spans multiple processes, you might hit the limit quickly. If you also stuff too much context, the model gets worse, it loses focus. You normally have to be intentional about memory and find a balance between what is important, what is not important. We normally have three. We normally think about it in three ways. There's a short-term memory. So the short-term memory is whatever the agent needs for the current goal. So this is what goes into the prompt, and it needs to be concise and focused to what you want to do. This is an analogy to it. It's like what is in your desk at that moment. So what do you need for this current task that you have? Then there is the episodic memory. So episodic memory is the history of what the agent has done in the current session, like not the current task, but the current session. So you don't pass this to the model, but we keep it in the process state. If I use Casa as an example, if you prompt it to do something for you, it normally breaks it down into steps. So the steps is what is stored in the episodic memory. So once a task is finished, it goes back to the episodic memory. We identify we've done this task, then we're going now to the next task. Then there's now the persisted memory. The persisted memory is basically historical context from past interactions. You normally don't have to use it every time, but you only use it when it's necessary. An example for this would be, for example, a RAG application, or
Yeah.
you can just retrieve whatever you need, then use it for that moment.
Would you, with your persistent or long-term memory, would you also, consolidate the knowledge base you have? So you've taken the agent has taken a particular flow. Would
Mhm.
you consolidate this flow into something a bit more high level to reduce the volume of data you store, or do you keep everything?
No, you don't keep everything. Actually, you normally don't give it. You only give it everything that you need. For example, for us, we are using it for a very specific purpose. For example, if an agent is just supposed to research about a lead, like that is a very specific purpose. So whatever we need to store on the long-term memory is maybe how we would want to structure this information so that we can get it into the different tools that we have.
What existing agent frameworks are there in Elixir today? And how does that compare versus rolling out your own?
In Elixir is just a tool that we can use to access different models, but there are various models from OpenAI, from Anthropic, from Google. These models are already pre-trained with a lot of data that we don't have. It normally costs a lot if you're to train a model from scratch. It costs a lot to do that. So it would be better if you just use the existing tools, then build around it. The value is in what you build around it, and getting it to another level. And if you need to do different things, you can just fine tune it to do different things. You'd need to build your own model if For example, you are working with very sensitive data. I can give an example of health data. I remember when you are doing the health project, we were not allowed to use the existing health data to train existing models. That was why there was conversation to build a model from scratch. But now you can only do that if you have a lot of money to spend on that.
How did you solve it at Nexuscale?
For Nexuscale, we just utilize the existing models, for example, OpenAI. So we just fine tune it to fit our use case. We fine tuned most of the models. We've tried out OpenAI and Gemini. We've also used Gemini a lot for some things.
I'm kind of curious about failure, how you handle failure, right? Because if you have this AI agent and it's going through a workflow, it's going to have lots of data and things happening. Of course, in Elixir and of course Erlang and all the other Beam languages, we had this idea of let it crash, right? So, but when it crashes, I mean, that's a lot of context that you're missing. How do you
Yeah.
handle this kind of context reloading? I mean, is that very complicated if it's been such a long running process of the agent, or how do you handle this kind of thing?
How we normally handle it is it's already in a supervision tree, and each agent has its own state. So if it fails, we'll just restart that agent, and it will continue doing its work.
What if it was
But
corrupt
that
state which caused? What if it's corrupt state which caused the agent to crash? And
if
you just go in and
it's
reload it, you're going to get the crash again happening again.
but if it's corrupt state, that means you didn't pass the right state to that agent. But most of the times, unless it's an API failure, I think you'll always get a response. It's just that it will be very bad. So you just need
Or,
to know what to pass into
or
your state. You have to be very specific. That's why I said when you're dealing with the context, you have to be very specific in what you want to do, the outputs that you want. If it's, for example, if you want a structured JSON output, you have to be very specific about that, especially in the prompt. Like here, the prompt is everything. Like if you mess up the prompt, you'll get really bad results.
when we used to design systems, you focused a lot on the restart strategy. So, you didn't know if it was a bug in your code or if your state had gotten corrupt, which caused the process to crash. Those are the two main reasons for failure. And so what we did is in a restarting, instead of just storing the state persistently and reloading it, that was really dangerous because you could get cyclic restarts if the issue was in the state. We would try to
Yeah,
recreate the state going straight to the source. In this particular case, it could have been, a request, to the LLMs, which, in the prompt, which, corrupted, it could have been a prompt which corrupted the request. So we would, go in and we would go in and recreate that prompt and go in and request it again, hoping, that things went right. And those were the different strategies which we would use, to recreate the state. Obviously, it's easier said than done, and especially if you've got a long history and a lot of data. But
yeah,
there needs to be points where, okay, everything's good. Let's take a snapshot of what we have, and so what you would recreate is from that snapshot onwards.
yeah,
This is the philosophy we used in the telco space, which we've then applied to digital health, to fintech, and, to a certain degree even AI.
Well, I think there's a term for that, where you just kind of, it's like an append only kind of state, right? And once you have,
the snapshots would really help. When you are talking about, I was thinking about it. If one agent crashes and it's because of the state, that means if it got context from another model, would you need to restart the whole process, which might be
Yeah,
might not make sense. But if we keep snapshots as we move along, like you'll know where to start from in case of any
that yeah.
failures. But that's an
This is
interesting.
this is where your supervision strategy kicks in, because if agent A dies because agent B corrupted its data, you need to restart agent A and agent B. And so what you usually try to
Yeah,
do is, okay, let me restart agent A. Oh, the restart failed. Okay, let's escalate it. Let's restart agent A and agent B, which A has a dependency on. And so agent B recreates its state, and then agent A restarts, retrieves the state from agent B, and hopefully at this point, the issue will have been cleared, and they all restart and continue executing. This would be, yeah, this sounds like the approach you're describing. taken care of in the supervision trees themselves. Interesting.
Are you using voice within your AI? And if you are, how do you kind of guarantee the response? Because if you're typing something, it's much faster, I believe, for the computer to go through it. But if you use voice, then you have to still, understand accents and what they're actually saying, plus bad connections, so on and so forth. How do you kind of guarantee
Yeah.
that response times are in a good response time? You're not making them wait too long.
For Nexascale, we are not using voice at the moment, but I have played around with voice AI, and it's very interesting, but also a bit tricky because, for example, for a chatbot, if you type it, someone can tolerate like a 2 minute wait time, but for voice, over half a millisecond will sound unnatural. My initial thought was the classic pipeline where you transcribe the speech to text, then through an LLM or through an agent, then later on you synthesize the text to audio, then send it back to the user. But now that would bring a lot of latency because you're running it in a three-stage sequence. So I have been looking into various models that I can use for voice, which can take in voice and just return voice. But if you're using something like Twilio, for example, for calls, you can just use the Twilio markup language, which will give you text, then pass it through a model, then it will now convert the text to audio. But still, the best solution for this would be to use an existing model that would take voice and return voice and also can be trained on different accents, for example, or how you'd want it to sound.
But it's also not just on accents too. It's also on the words. I tried using
Yeah,
some transcription for this episode. For previous episodes, I tried to cut clips from. I pulled out the words using a transcription tool, and I stuck it into the AI to see if okay, can you pull out some clips for me? I mean, I think Erlang had a couple of problems and some other ones. I remember when I had an Alexa on my desk, every time I said the word Elixir, Alexa would wake up and say, what do you want or whatever was the prompt. So it gets quite annoying. Language is so tricky, especially like I'm in Hong
yeah,
Kong and Chinese. Like a tone can make a big difference, and even the same tone can be different words. So the only way to actually make it very clear is having the character. Otherwise, it's very complicated to know what you're talking about, and also the context too changes a lot,
and
right?
it will get better with time, with more training, and because we have more text data. That's why right now models like ChatGPT are really nice in terms of text. But now for voice, like we don't have a lot of data on voice, so I guess it's something that is still growing. But in the future, it will be widely used because voice is more natural than text.
We're struggling with text and all of the errors the models are returning, the levels of them handling load regulation and back pressure. It's felt like we needed to build a whole resilient layer around these models and these agents ourselves in the systems we worked with, to the point where we'd almost like to come in and host our own, because at least you've got control over your own destiny. Right now, yeah,
Yeah,
you send a request and something fails, and we are doing quite a bit of voice, but luckily all we're doing is transcribing, and the speed isn't that critical. It's still very asynchronous. So 30-second wait in the use cases we're working on are
okay.
acceptable, at least for now. At least for now,
Yeah,
getting a 30-second answer. But yeah, it's going to be interesting to see what happens when you start streaming. You've got a voice conversation, active voice conversation going. That's yeah. At that point, immediate response, become critical. But I'm wondering, Ali, we could maybe add a few ums and ahs there in between, to keep the conversation going. That would help. One question came: is it better? Yeah, I think we covered this already, but is it better to use existing models or to build your own? And is it better to use hosted models, or should you be hosting them yourselves? What are the use cases for them?
I'd say most of the cases you'd use existing models, but there are moments where you'd need to use a hosted model, but it just depends on the use case. An example I can give from what I've worked on before is we had self-hosted Llama Llama is a model from Google before for the health project, and we tried using it. But self-hosting, yes, some people like self-hosting models. Some people just use existing models, then they move with it. But for self-hosted, I guess you'll still need to do a lot of fine-tuning to suit your use case. Then you can be able to use it. But I guess it normally depends on the current use case.
Can you give specific examples?
Specific examples is, let me use an example of voice. For example, Canon, for example, we sound a particular way. If I'm building a voice model that is being used in the Kenyan market, for example, I can have a self-hosted model that is trained on data we've gotten from people who live within this region. Then we'll use that to, you'll just train using that data, then it will sound natural to that region. That's an example of when you need to self-host a model. But now for using existing models, I guess the applications are limitless. You can basically do anything with it if you're building a simple agent that does research or it writes articles and so on.
What mistakes do you see people making when they first build AI agents?
The most common one I'd say is prompting is the prompt because as I said, the prompt is what will make a model good or not or bad. So people assume the model is smart enough to figure things out by giving it a vague instruction, but a vague system will produce inconsistent results. A prompt is not just a configuration, but it's everything you need for a model work to work very well. And it should also handle edge cases. Ideally, you should spend a lot of time on the prompts than every other part of building an agent. And it's a common problem. I've also faced that issue before as I was building out these systems. And another common problem is treating an agent as a chatbot. You build a system that maybe responds to one-off requests and works in a demo. It might feel impressive, but it has no real state management, no persistence, no ability to execute multi-step tasks, and it forgets everything within interactions. So it cannot, for example, it cannot pick up from where it left, and it's an LLM. It's basically an LLM wrapper. It won't be an agent or a fancy autocomplete, as I can call it. Yeah.
Yeah.
And
Okay.
another common issue is giving the agent too many tools. I normally prefer having more agents with less tools as opposed to more tools with less agents.
I saw you're talking at ElixirConf EU in Malaga. Can
Yeah.
you tell us a little bit about your talk?
For the talk, it's basically a mixture of what we've talked about right now, or how you'd set up an agent using Elixir, using in the supervisor tree, and also having the dedicated Zen server, having the brain, having the context, having the tooling aspect of it, and actually started on a project for that, which was a CLI to that basically works like Claude, but it's fully built on Elixir. I'll actually make it open source. Yeah, but that is what we will use. That is what I'll use to demonstrate how to build these agents using Elixir and how Elixir is
Will you,
really good for this.
will you be tempting the demo gods, or is it going to be a more traditional talk?
I think it will be a mixture of both.
No, it's interesting. There are a lot of really interesting talks, and there's a lot happening in the AI space. So it was really hard to go in and pick interesting talks, without creating an AI overdose, because I think we're being I think we've covered it pretty much in every single episode of this podcast because it is affecting and influencing us. But at the same time, yeah, we don't want to come in and forget, the foundations on top of which everything is built on, which to a certain degree we also discover a lot. We talk a lot about on this podcast. It's and that's when your talk came out, I think it was really we thought it was a real kind of real world. It was based on real usage and a real company with real problems which you're solving. And it was really
Yeah,
interesting, to go in and getting this case study, getting those case studies and getting that feedback back. So yeah, really looking forward to meeting you in person there and listening to your talk.
Yeah, looking forward to meet you too.
Yeah.
Because you're already in this area. I haven't done a whole lot with agents, and I'm curious
Mhm.
about where do you see AI agents going in the future, right? I still feel that we're at the very beginning of agents and what they can do and how much we want to let them do. Now that you're actually working with them, you're getting
Yeah.
to talk about them. How do you see the future of AI agents?
I think the future is big. A lot of people will start adopting agents because we are past the era where you just need a chatbot that just responds to questions. So right now you need to keep track of context, and there are also very many use cases that agents also can be used for, and that's why it will really grow. And there's also upcoming protocols that regulate, I can't say regulate, that define how agents communicate with each other. For example, MCPs, which Anthropic came up with. Yeah, so it's very, very interesting to see where this whole conversation will go. But it will be a very, it's a very open field where there are limitless opportunities for agents, in my opinion.
How do you drive forward this innovation?
One is I told you I was preparing an open source CLI for that is built fully in Elixir, which will also enable people to see how Elixir can work with these agents, how to build agents using Elixir, and how to avoid particular mistakes that we've done before, and also to improve on the responses of the agents they're building. Another thing would be to also encourage people to build more using the agents for their use cases instead of just making vague calls to these existing models, then just giving out the response. If you think about an agent as a Gen server, I think that I normally tell my friend that Elixir was just built for AI, basically. I don't know. It's just a natural fit, in my opinion.
I perfectly agree for you. I agree with Erlang. Was built for for the internet, even though it predates the internet. It was built for multi-core, even if it predates that as well. And this whole concurrency model, the ability to orchestrate, the ability to take these processes which don't share memory, which don't have shared memory, but share information through message passing, into a supervision tree allows you to control full tolerance and
Yeah.
all really lightweight, allowing you to scale and really utilize modern day hardware architectures is the future. Thank you so much for being with us. Yeah, really, really enjoyed it. Alan, do you have any questions you want to wrap up with, else?
No, I feel like almost like what you said before is that we touched on AI so much in basically every episode. And I think Jose's
Yeah.
episode, which at the time of this recording hasn't happened yet, hasn't been released yet. We talk a lot about this, so I think that's a great episode. So that should be released before this episode comes out. So if you didn't, then definitely check out that episode because we go quite in depth about why and how Elixir, and therefore I basically any Beam language is really perfect for developing these kinds of applications.
They were using Erlang back in the late 2000s to teach artificial intelligence in universities. And and it's an ideal language for the very reasons we've covered today. It's just that the topic now is now we actually have the tools and the computing power to integrate it into our day-to-day applications. Thank you so much. And just for the record, this episode was recorded on the 16th of March, 2026.